the three Kepler laws. First, all planets move in elliptical orbits with the Sun at one of the focal points. Second, a line drawn from the Sun to any planet sweeps out equal areas in equal time intervals. Third, the square of the orbital period of any planet is proportional to cube of the average distance from the Sun to the planet. First law: all planets move in elliptical orbits with the Sun at one focus. Any object bound to another by an inverse square law will move in elliptical path. Second focus is empty. First focus is placed to the Sun. Second focus is empty. That means the Earth in its revolution orbit is in a point called aphelion. This point is less close to the Sun and its distance is about 152 million of kilometers. In the other point of the revolution orbit, Earth is more close to the Sun, and the name of this point is perihelion. Its distance, the perihelion distance, is about 148 billion of kilometers. Ellipse parameters are the semi-major axis A, and semi-minor axis B. Eccentricity. Second law: a line drawn is called a radius vector. From the Sun to any planet will sweep out equal areas in equal times. The area from A to B is equal to the area from C to D. That means the orbit from the revolution orbit from the A to B is more length. The orbit from the C to D is less length. Now, the Earth must sweep up these areas in equal times. Therefore, the Earth is more speed in perihelion to sweep out these areas in equal time to this area. So the Earth is more speed in perihelion and less speed in aphelion. Third law: the square of the orbital period of any planet is proportional to the cube of the average distance from the Sun to the planet. This is the formula. Period in square and equal constant to the distance in the cube. T is the period of the planet. D is the average distance from the Sun, or A is the length of the semi-major axis. For orbit the Sun, K is equal Ks. This is the value. Ks is equal 4 pi Greek in square fract G is the gravitational constant and m is the mass of the planet. K is independent of the mass of the planet. That means that if we see two planets P1 and P2, the ratio of the period T1 in square and its distance to the Sun in the cube of planet 1 and distance 1 is equal period planet 2 in square fract the distance in the cube of distance of the planet 2. This T ratio are equal, and this is a proportion.